Okay, let's try this take two. I'm homesick today, so I apologize for how terrible my normally beautiful voice must sound. But I wanted to do some sort of pre-lab for the spam filter because I've set things up to make it easy to test, which means we're doing everything using interfaces in Java. So things we want to talk about. I'll talk a little bit about the iClassifier interface. This is a Java interface, which means it's like a class, except it has a bunch of method declarations but no method bodies. And this is defining all of the methods, the interface or the API that any class that wants to be a spam filter or spam classifier is going to need to implement. We'll talk a little bit about training data and actually show you what the training data is going to look like in Eclipse. And then I want to go over the filter methods and talk about how you're going to test it in JUnit. In the real world, you will have to write your own JUnit test cases for everything. For this, I've written most of them for you just so that I can have an easy way to get you started so that you can get this done in a couple of weeks. You should actually be able to get this done pretty easily because I'm giving you so much material to get you started. But it is a fairly large lab, so a lot of moving parts that you have to keep track of. So the interface, well, before we get to that, I'll show you what we're looking at. You're going to get this Eclipse project spam filter, and you'll have a source folder, and in the source folder you'll have this base.classifier package. You won't have the base classifier solution package. If you do, please let me know. That means I've accidentally distributed the solution again, which I'm going to try really hard not to do. I did that a couple years ago. It was really embarrassing. Inside this, there's going to be 4 classes. iClassifier, this is an interface. So if we look at this, you can see it's got a bunch of methods, but there's no method bodies. There's just a semicolon here. There's just a method declaration. Of course, it's got all these java.comments comments that go with it. This is defining all the methods that are necessary to implement your spam filter or your spam classifier. Now, you're also going to have this spam classifier class. This is an actual class, and it's going to implement that iClassifier interface that we just looked at. That means you're going to inherit all these methods, and in order to make this a concrete class rather than an abstract class, you're going to have to provide method bodies for all of these methods. So we've gone ahead and done that for you, except we've provided you with incredibly unuseful method bodies that just all throw unsupported operation exception. This is an unchecked exception. It's just going to crash the method when anything's called. As you start writing your code, you're going to replace this line with your actual code, and then up here somewhere, you'll start adding your instance variables because you're going to need instance variables to implement this assignment. Now, these other 2 classes up here, basic filter test and enron spam test, these are JUnit test cases. They're going to read in some data to train the spam filter, and they're going to then run some test cases against your spam filter once it's been trained. Now, we're going to run the test cases for data that we already know the answer for. And the first one we're going to start with is test 1. So test 1, you can see, is split into, this is a folder. Inside it, it's got a ham folder and a spam folder. Now, if you open up the ham folder, there's 2 messages. If you open up the spam folder, there's 3 messages. Let's look at this first ham message. Foobar is a great sentence. Let's look at this second message. Totally legitimate ham message. Please send me a ham sandwich. Ham is great. That's really interesting. These look like the examples that we saw in class. In fact, they're exactly the examples we saw in class. See how prepared I have you? You're ready to go. So basically, this file here, this isn't used by anything in the project, but it's just, this is test1.txt that we did our spam and ham stuff in class with. So this is how these folders are going to be organized. Test 1, it's going to have a ham folder and a spam folder, and it's going to have some number of messages in each. What you're going to do is create an instance of this spam classifier, and then you're going to tell it to go ahead and read everything in here. I say you're going to do these things. Actually, JUnit's going to do these things for you. It's going to read all this stuff in, train a bunch of probabilities, and then you're going to try to classify new messages, messages that you've never seen before. So that's what test 1 looks like. Enron 1 also has ham and spam. It has these other ham tests and spam tests, which I've used for grading in the past, so those may get distributed to you, but I don't think you need to do anything with them. If we look in here at ham, you'll see there's thousands of ham messages from back in 1999, and if we go in here and look at them, this is what we've got. They've already been tokenized and put into a format that's very easy to read. So like, all these dashes have been broken up, everything's been converted to lowercase, all the punctuation's been kind of split out, so it's actually been very nicely processed for you in a way that's going to make it really easy to get in there and read. So your job is actually going to be fairly easy on the text processing side of things. Now, what you need to understand in this iClassifier is what all of these methods are doing. So what I've gone ahead and done is apparently I have too much time in my hands, which is not true at all, but whatever. Is I've put together some slides sort of explaining what each of these methods did, because I answered the same questions last year and the year before for this assignment approximately 300 million times. So I want to try to get as much of this stuff answered ahead of time as I can, so that more people can get the lab to the point where you can train it on your own data and do really fun things with it. So these first two methods, add ham file and add spam file, once you create an instance of your spam filter, you can then call this method, give it an input stream, or call this method and give it an input stream. That's going to read in a bunch of message that you read in a message that you already know is ham, or a message you already know is spam, and update whatever internal probabilities or data structures you are storing. Now, you'll notice we're not reading a file, we're reading an input stream. An input stream is more general than a file, because an input stream, you can actually get one out of a socket if you're reading over a network. File input stream is a subclass of input stream, and that will read from a file. And there's a number of other types of input streams. In fact, system.in, when you create a new scanner to read from system.in, that's actually an input stream. This is a very, very general way to create something to read input. You don't want to target specifically a file or a file input stream, because that limits you to only working with files. This is much more open-ended. It allows you to read from any possible input stream in Java. Input stream is a base class that has many different types of subclasses. So this is for reading a single file. Now, here, this is for reading a whole directory of spam and ham files. Now, you'll notice these are different methods: add all ham files in directory, add all spam files in directory. These are actually targeting a file, and the reason for that is you can actually take a file and ask it to list all of the files that are inside it, assuming that that file is a directory. If the file's not a directory, you'll get an exception. The method's just not going to work. Now, one thing to keep in mind, if you've implemented these first two methods correctly and you're pretty confident they work, and maybe you've tested them on a simple example, you can then write these methods by calling the previous methods. It just will make me very unhappy if people sort of cut and paste rather than just call the method. Like, call the method if you've already implemented and you're pretty sure it's correct. You're much less likely to make mistakes that way. Here we've got get number of ham messages and get number of spam messages. So on the previous slide, we can add a bunch of ham and spam files. Once we've done that, these methods will tell us, well, how many ham messages have we read and how many spam messages have we read. This is useful because we need to know these things to start computing probabilities. Here we've got a couple of other methods: get number of ham occurrences given a string, so for a particular word, or get number of spam occurrences given a particular string. So this means that on these previous slides, when you're reading in files, we know if the directory is full of ham files or full of spam files. As you're reading them, you have to remember what you're reading and keep track of where it needs to go and what kind of message those words are occurring in. And so this will say, okay, for a given word, like for example, foo, how many ham messages does it occur in? And for another word like, bar or foo or whatever, how many spam messages does it occur in as well? These are the spam thresholds, so you can get the threshold and set the threshold. The threshold, this is the fraction between 0 and 1 at which we're going to decide something is spam. So if you think about our Bayesian probability that a message is spam given that some number of words occur in it, that's going to give us like 0.73 or 0.5 or 0.9 or something like that. The threshold is the number at which we're going to say, well, 0.5 is the cutoff. If the classifier says it's 0.5 likely to be spam, we're going to say that it's spam. Because remember, everything here is probabilistic. We can't say for sure a message is spam or ham unless we classify every message individually, and given that over 80% of emails sent is in fact spam, it's actually much easier not to do that. It's much easier to train these probabilities and then just sit back and let the classifier decide what's spam and ham, depending on how far, whether it's above this threshold or not. So if we want to ask what's the probability that a message is spam given that a certain word occurs, well, we can go ahead and do that in terms of this method. So this method's going to say probability of spam given word. We give it a word. It's going to actually do the Bayesian calculation. Now, this might need some number of helper methods that it's going to call, or however you want to implement that. But basically, that's what this is doing, is spitting out probability of spam given that a particular word occurs. Now this probability of spam given that some sequence of word occurs, to give it the sequence of words, we're actually just going to once again give it an input stream, which could be an input stream connected to a file, or it could be over the network, or whatever else. It actually, as we're going to see in the JUnit examples, can in fact just be a list of words which we then are going to turn into an input stream to call this method. So this is going to compute this for a bunch of words. This is where you're going to have to do your, using the log function and whatnot. It's going to spit out a probability between 0 and 1, how likely it is that this particular message is spam. So let's look at JUnit now. So our basic filter tests, and I'm going to go ahead and, this is in my way. You can't see me moving that. That's the little icon that I'm recording the screen from QuickTime. So basic filter test, this is a JUnit test. JUnit is a set of conventions, really, and libraries for Java that lets you write methods that basically act like little mini test cases. So it's like having a class with a bunch of methods in it, and each method is like a mini main method. And then what JUnit does is it invokes all of these methods one after another and keeps track of whether the method succeeds or fails. If it succeeds, that just means it ran, didn't throw any exceptions, and got to the end of the method. We're going to call that a success. If it throws any exceptions, we're going to call it a failure. And if any assertions fail, that's going to throw a special exception. We're also going to call that a failure. So you can see this has got one instance variable, an instance of our spam classifier. That's the class you're going to implement. These little things here with the @ signs in front of them, these are called annotations. These don't do anything programmatically. They don't have any function, like you can't invoke them or anything. They just mark certain methods to have certain meanings. That's why they're called annotations. They annotate code that does do things. So when JUnit needs to run this, it's going to say, oh, this is listed as before. What we're going to do with that is, sorry, I hovered over that. We're going to go ahead and invoke this method before each test case. What is this method doing? Well, it's creating a new spam classifier. That's the class you're going to be implementing. And it's saying, I want you to add all ham files in this directory and add all spam files in this directory. What directory you're looking at is test1 ham and test1 spam for the ham and spam. And so if you've implemented these methods correctly, it's going to go ahead and read all the files in the ham directory, read all the files in the spam directory, and then update whatever things that you are tracking. Now we've got different test cases. Test threshold. This just tests that you can go ahead and set the threshold to 0.4, and it's asserting 0.4 the expected value if we take your spam filter and get its threshold, it should be 0.4. Now, for the assert equals with doubles, because of possible rounding errors, it has an epsilon value here. I have this set for a constant. This is just set to 0.001. So what this means is these have to be the same within 0.001. That's what the epsilon value means there. Now, if this assert method notices that these are, in fact, within 0.001, it doesn't do anything. This method will go ahead and return, and everything's fine. JUnit will mark that as a success. But if these are not within 0.001 of each other, like, for example, we set the threshold to 0.4, and then we assert that 0.4, and we ask your spam filter what's its threshold, and it says it's like 72, it's going to throw an assertion failed exception. JUnit's going to log that as a failure. So here we're testing some basic stats. Now remember, before any of these test cases get invoked, all of this setup code happens. So we're reading ham and spam, and we're asserting that 2 is the number of ham messages, 3 is the number of spam messages, 1 is the number of spam occurrences of foo, and 1 is also the number of ham occurrences of foo. You'll notice that a lot of this looks very, very similar to the work that we did in class Monday, Wednesday, whenever it was. I probably shouldn't put specific dates on things in case I use this lecture again in the future, but in the days leading up to this assignment. And so this is one of the test cases. Then down here, test foo, we're going to ask, well, what's the probability a message is spam given that the word foo occurs? We're going to sort of read out this W1. Then we're going to assert that it's within epsilon of 0.5. And if you remember from our example in class, the probability a message is spam given that the word foo occurred was, in fact, 0.5. And this one should come back pretty close to exact. And then we've got other cases, test please, test by, test please by foo. That was another example we did in class. Test please by great replica foo. And then I'm working on some other ones to add in. This method here is a helper method, this string to input stream. So up here where we want to test a bunch of words, remember this this method here, probability that something is spam given a message, actually is connected up to an input stream. So what I'm actually doing is taking this string and turning it into an input stream by taking the message, converting it to bytes, and then wrapping it with a byte array input stream. So that's just like a really cheesy way to take a string and make a stream, an input stream that actually can read from that string. So I made this a helper method, which I'm sort of invoking here in the test cases. One interesting note about well, there's many interesting notes, but an interesting note about test cases and JUnit, you can actually spend a lot of time writing test cases, and writing good test cases is actually very hard work. There was some speculation at Google that Google heavily uses JUnit for all their Java code. In fact, they use some form of unit testing for basically all their code. And when a test case failed, it was as likely there was an error in the test case as there was an error in the code the test case was testing. So that's something that had to really be kept in mind. So that's just a bunch of simple examples. And remember, all of these are based on this ham folder and spam folder for test 1, the examples that we did in class. We've basically turned this into JUnit, turned it into code. So all those methods that you're going to be implementing, that's what they're doing, is they're going to compute all of these probabilities. Now, one thing you should be thinking about is what data structures do I need? I'll go ahead and put that as your review question for this one. The nrun spam test, if we look at this, it's basically the same sort of stuff, except now instead of using that test1 folder, which is very small, only has 5 messages, 3 spam, 2 ham, this has got, I don't know, like 5,000 or 6,000 messages in it, so it's going to be much slower. And what I've done is we're sort of training on the entire thing, and then what these ham test and spam test folders are used for, I've actually grabbed a couple messages and pulled them out ahead of time, and then we're going to go ahead and train on this stuff that's been pre-classified. Then we're going to test using a message that we've never seen. This message is from the Enron1 dataset, but I've put it in this special ham test folder, so we're not training on it. It's important that when you're training a classifier, or training any other kind of machine learning or AI thing, you want to hold some stuff out of your training and then test on that. It sort of pollutes the results if you take the stuff you've trained on and then also go ahead and test on it, because it's already seen that and known to classify it to some extent. So you could be getting biased results. Cool. So this is what we've got. I'm not entirely sure if there's anything else that I need to tell you. I think that's probably everything. Oh, well, I'll go ahead and show you what it looks like when this runs. So when I go ahead and run this, now remember everything should just throw unsupported operation exception. So this is what you're going to see. It's gone ahead and run each one of these test cases, and the failure here, you're getting this implement this method unsupported operation exception. But what's great is it's sort of running all these test cases one right after another. Now if I go into my little solution thing here and go ahead and run the same thing, I'm adding some new test cases, so not everything will pass. So you remember, these test cases are here. I'm working on some new ones. And so you can see down here, I've got an assertion error. The expected value was 0.5, but my thing actually spit out 0.0. And then, same thing here. So if you get a little green check, everything's good. If you get a blue check, that means you had an assertion fail, which means your code ran, but it produced the wrong result. If you get a red check here, red X, that means you had a runtime exception, like a null pointer exception, array index out of bounds exception, some sort of a crash. So that means your code didn't work and also it crashed. Excellent. So that is what we're doing.